circular one first, because that's really I think it's cool, sculptural. They're pretty stairs when they're all said and done. They have subtle differences between the other stair calculations. I think this one's a little easier, maybe less confusing than the spiral, visually when you start projecting. So let's just look at it. If you guys, everybody got their handout still? Okay, good. So here. So I sprinkled a little information on here. We're gonna be drawing these at 1/2 inch equals a foot. So the reason is, there's a lot more projection going on manually. So if you try to do it with 1/4 inch, you're gonna go crazy. So we're gonna make it a bigger scale to make the image bigger for us to then project all the appropriate edges that we're gonna see. I also put information, if this were to be used as one of the required egress stairs, you would have to follow this. The smaller radius cannot be less than 2 times the width of the stair. Okay, so it's called word problem. That's what a lot of codes are. You have to decipher it. So the inner radius cannot be less than 2 times the width of the stair. So if this is 5 feet, this can't be less than 10 feet radius. If it's used as a required egress, like in a hotel or something, in a lobby or something. Right now, we're not gonna worry about that. So we're designing in a vacuum. You're just designing a circular stair, and it also depends on your compass capacity. What's the maximum radius you can do? So when we do this, we're gonna do 5 foot wide. I want you to do 5 feet wide on these, okay? So it's gonna be 5 feet, it's just a nice width. Whoops, it's not too small, not too big. The tread depth, now like the other ones on the stairs below, it's 11-inch minimum tread depth. But on circular, they allow you to go 10-inch at the minimum. The least dimension along that inner radius can be 10-inch minimum. The reason is because as it radiates out, it's getting wider automatically. So your stair is getting wider. Nobody walks right along the edge of the stair, right? You're gonna be walking more in the middle, so you're fine. That's one of the reasons they give you that break. For our exercise though, just for the ease of measuring manually with our scale and using our compass, we're gonna do all of ours at 12 inches. And what that's gonna do, it's gonna elongate the total run of the stair. In reality, if you were designing in a real confined space, you would use all these allowances to let you get away with a shorter run, maybe you have to in order for it to work in your particular design. But right now, we're just gonna do 12, it's easy to measure manually, okay? Everything else, again, we were pretending, again, I showed these 2 lines as if this were a wall. Maybe this is enclosed in a wall of some sort, and this thing's just going around. And we're gonna just still express everything as though it's invisible, so we can see the railing and the stair stringer. So we're still gonna be projecting the 2 inches in, which is really 1.5 inches. But manually, we're gonna draw 2 inches in, 2 inch for the railing on each side. Same thing when we start, we're gonna have our minimum 12-inch level before it starts to slope down. Once it does, then it's gonna continue past this last riser at the landing. It's gonna go 1 tread depth, which would be 12, and then it radiates out, so that would be a tick there, and then it would come out here and there'd be a tick here. And again, it's not real clear on that copy. You'll see it when I show you a sample a little clear. The other thing, so to be safe as well, if there's a landing in the stair, we're gonna make the landing depth at least as deep as the stair is wide. So again, we can always go deeper. Let's say we're doing 5 feet, it has to be at least 5 feet here. I would do it. I think it's really, the code might say it's in the middle of the path of travel, but to be safe, I always play it safe, because I don't wanna get a lawsuit, and how people interpret the code. I would do the 5 feet here. You're always gonna say it. So again, once you measure it, so it's 5 feet, and then each tread is 12 inches, how many treads do I walk off, spaces in here? If I were to do it. 5, right? So you would do 5, and then that's where the next riser would start, and then it starts going down to the end, and that's why these are kind of showing they're going out. In reality, they're not gonna stick out and, and jab you. They're gonna turn around and become like a little newel post. And you'll see them on fancy stairs next time you go around. So when we do this, you're gonna end up 2 sheets of paper for each one of these, or for this one for sure. Because you're gonna be doing the plan first. The plan has to be calculated, I'll give you the height, but then you're gonna be doing like that. So this is at 1/2 inch equals a foot, so you're gonna start it, I don't know how, again, it depends on where you start. Again, we'll have our center point, right? Then you decide, well, I wanna start perpendicular to that. It could be up here, it's up to you. Everybody's could be different. But you start here, and then you'll be counting off the number of risers you need. Up to you, how many you have here before the landing. It's up to you. This landing could go anywhere in here, as long as the distance between landing and floor is less than 12 feet. Vertical. So, and you wouldn't dimension like that. Don't dimension like you're seeing on some of these, they're not the best method. So when you do this, you're gonna be drawing, take your compass on a piece of paper, how big your compass goes, draw a circle, and then you're gonna measure 5 feet, draw another circle. Then you're gonna determine where you wanna start. Then you take your compass, and I don't have one handy right now, but take your compass or your divider, measure 12 inches on your scale, and you start here, and then you tick off the inside edge of the radius here, and you mark where each tread's riser is gonna go. Just like that. And then when you get to the landing, you count 5. You just go 1, 2, 3, 4, 5. Then you'll start another one. But this determines, see, here's where that railing transitions from a slope to a horizontal rail. So when you radiate out, you're radiating out from the center point with your triangle out like that. Everything's radiating out. So they're all the same, all the wedges are the same. Then, and again, it's just an exercise more in projection and visualization. Then you have to have another piece of paper below it. So you're gonna be taping this on your board, and another piece below it, and then that's when you're projecting. So you gotta project from this down to the elevation. So the elevation, I guess I can't go out anymore. But it's like this. So it's projecting one at a time. You do the same thing, floor to floor, but you're using 1/2 inch scale, floor to floor. Subdivide it same way you're doing all the other stairs. And then you do 1 tread at a time. And as you see it, you're looking at it, these risers look like they're getting smaller, right? That's because it's curving away from us. So if you were to stand here, look at it. That's why you do 1 riser at a time, 1 step at a time. I stand here, I see the full width. But if I keep looking at it, it looks like it gets shorter. Because I'm projecting perpendicular, always perpendicular down. Edge, 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 edge. See how the wedge looks like it's getting smaller? Eventually that one might be head on. It's actually not. But, it'll be a little the other way. And then that's when you start dashing it. So then I want you to dash the back edge of the riser. So it's the inside edge, then the outside edge. At some point it flips. You're gonna have the outside edge is what's visible, and then this inside edge is where it's hitting the riser is angled back, and we're seeing the back side of the riser. That's where all this is, so I wanna see that. So again, make your life easy, just keep it an open stringer, it's the easiest way to do it. And then again, follow it all the way around, and then here, keep it smooth underneath. That's the easiest way to depict it. The underside of the stair is smooth, so that then you're concealing all those steps of the back sides of the treads and the risers. So then you just dash them though, but then see how this is now the inside of the stair, circular, and then the outside edge, and go this way. Now the railing is another step. So at first you would do the stair, then I would go back and add all the railing. The railing is similar to what you're doing on the straight run stair, U-type, similar, but it's easier with a straight rail, right? Here we're curving, so what we have to do is visualize. You have to develop visualization here. So imagine we're looking down on top of, this is the top of the rail as it's going around. You don't want to see the edge of the riser, the tread underneath here. That's why it's erased, it's clear. Same should be happening on your other stairs that you're doing at quarter inch. But you visualize the highest point of the rail is right in the middle of the rail, in line with that riser. A little dot, if you can imagine a little dot. So you go like this, like this. Imagine that would be the top of the rail. Again, this is it would be a circle. I mean, it's just a little isometric sketch. This is the highest part of the rail as it goes around. In line with that, that's what you're projecting down. Once you know where that point is, you take that point from each step, one at a time, and go straight down. One at a time. So it's gonna line up like this. You know, I can't tell where it lines up. It goes like this. And this person did a kind of a rectangular railing. We're just doing a round one. Round ones are a lot easier. You can fudge it a little bit manually. So you're gonna go like this. You find the highest point there. And we're gonna call that good, okay? That'll be our edge that we're gonna connect the dots. We do one at a time, like this. Each step, each imaginary point relative to the middle of that railing, it'll get you close. Again, manually it's a little trickier. And then you do the outside railing and then the inside railing. And see how they kind of merge together here? All right, that's the landing. This is the landing, and when you look at it, that's where it ends up. Again, there's just a lot of projection on these, on the circular, for sure, tons of projection. But you can see this is where the two, if I were to visually look, this is where they line up. Here. That's the flat part. So that's what you're seeing here. Any questions? Again, this is the toughest one. This is the toughest one. So there's a lot of projection, but it's fun. I think once you do it, again, it's a beautiful stair at the end. I mean, if you do it right, it looks really nice. You don't have to shade it if you don't want. I can help you do that, but you gotta imagine it. It's curving visually. Sometimes it helps visualize it. Also, we'll just do the stringer. We're gonna do our stringer at 2 feet. This one I think is 1 foot. Let's do 2 feet. So it'll be a little more substantial as it cruises around. So that's another thing you do. You would just take each point, and again, it can go quick. You just do a layout line down, take your compass or divider, measure 2 feet, and then you just go like this, tick, 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 like that. You put a little dot, 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 dot as it goes, and then you connect with your flexible curve, your flexi curve. And you just do little sections at a time with the flexible curve. Same thing with the ramp, the stairs. So we kind of calculate where the top is, and then we're just going to measure about 2 inches down, and we'll call it good, just make it parallel, and that looks fine. The circle's it's twisting as it's going around. There's a lot more going on than I want you to do manually. Any questions on that? Again, this one's the challenge, this is the big challenging one right here. Now, let's do the spirals. Put that there. So the spiral stair, this one has its own design criteria because of the conditions that it's used. You know, it's seldom used for anything major. It's for limited access. So again, refer to code for those specific elements. There's minimum dimensions that you have to adhere to. If you have your support and you measure from the face of it 12 inches out, the distance of that minimum depth of that tread has to be at least 7.5 inches. So each wedge has to accommodate that. The inside to the railing, 26-inch minimum. We're gonna make ours bigger, again, just for the ease of projecting all the edges. We're gonna do our diameter, let's do 6'6". Okay, and that'll give us a little more to work with. So that's diameter, not radius. And so then when we're gonna put a 6-inch post minimum in there. If you were to go bigger, again, there's things you could do if you went like a big column, you had a 1-foot column in there. That's gonna impact the design criteria of all these steps. It sometimes helps you by achieving bigger tread depths to each wedge. But maximum riser height, so here it's still 7 inches maximum. The riser height for the circular is still 7-inch max. But for a spiral, we can go up to 9.5. Just due to the nature that it has to get around itself and still provide you the head clearance. You have to have big steps to do that. They're not the most comfortable nor the safest, so that's why they're limited to like lofts and storage, maintenance type access. And if we were looking at the top of the loft, so let's say the second floor, you can imagine that steel plate kind of going like this. That's part of the design. Okay, you don't have to draw that. Just imagine it, because what's happening is this. So you have this stair. You got your upper loft area. This is part of the manufactured spiral stair. And so if I go down, by the time I get down to this one where I'm going back under the circle, under the platform above my head, I have to have 6'6". From that one to here. That's the minimum. And so usually this is like 2 to 3 inches thick. This floor here could be 12 inches. So if that kept going, we could never make it work. So we have to cut out that opening so that this becomes one unit installed and provides us the clearances that we need. So just kind of imagine that, okay? Now, you can also look at it. So here I'm just gonna shade this. This is the second floor. That's why these are dashed. So if I were to start here, similar to all the other ones, we're pretending we're on the second level going down. Again, when you design your final project, there'll be times when you say up. But right now we're just saying down on all of our stairs. So down. So you calculate. I haven't given you the height yet for either one. I will. But you would calculate what's your total inches in riser height, floor to floor rise. Then you would divide by the height of your riser, or the number of treads you want when you count them. And by the time you get to this one, this is the one that's on that sketch, you have to be able to get 6'6" from that to the underside. So again, when you calculate it, if you were to do every 30 degrees, this is every 30 degrees, so you got 3, 3, 3, you would calculate what it is. And sometimes this stair will keep going, it'll end up right here, you know, it might end up here, and you have to exit out here underneath. Solid lines dictate over hidden lines, so if they coincide with each other, the solid line wins. So here I'm just showing, theoretically, we could have treads going underneath. So once you know that, you calculate that and that's all good, then you project from the plan. So in this instance, you're doing 1/2 inch equals a foot again. One piece just for the plan, okay? So here we got our platform, we started here, we calculated, we went down 1, 2, 3, 4, 5, 6, 7, 8, 9. When we're standing here, we're down 9. So if, I don't see their calculation on here, they forgot to do it, so I don't even know what the height was. This is on the elevation. Yeah, they did it here. So, okay, so yeah, so they did that. By the time you get there, I think they did 9-inch risers, so you get 81, which is more than 6'6", but you have to allow for the depth of that plate, that quadrant of the steel plate before you put the penny floor on. So those are, like I said, 2 to 3 inches. So your 6'6", which is 78 plus 2, that's 80. We're fine. We have 81 inches lower here, so we're good. And again, that all becomes a little more technical when you're specifying specifically with the shop fabricators. So then it goes like this, they're dashing this, showing the handrail. Here the handrail is just to the outside of the stair, that's fine, it can be attached to the outside. Then from the plan, again, the plan's always developed first, then you're projecting from the plan. Again, you're gonna have the plan up here, your scrap clean piece of tracing underneath, and then you're gonna develop your elevation, which is this. Again, ideally, I don't know why she chose to do rectangular handle. She did a nice job and everything else, but I wouldn't have done that. It doesn't bend well, you know what I mean? When you bend it, you can tell she wasn't familiar with fabrication processes. With a tube bends a lot easier than a rectangular. So here you got your support column. Again, you should show the platform over here, the floor depth. But the thing with the spiral stair is you try to imagine each of these wedges, each of those wedges as solids. Do them as solid blocks. Make your life easy. Where, I can't flip back and forth. Remember that one where it showed the wedges and then it had the open riser space in between? Then you would have to show more lines in elevation. Just don't do it. Let's pretend they're solid blocks. We can build them like that. So, imagine that. And so I always tell people to kind of imagine, my analogy is, anybody familiar with the little laughing cow cheese wedges? You know what I'm talking about? The little, you go to the store, you got a little round container, it has all these individually wrapped cheese wedges. So that's kind of what you're doing. You've got these cheese wedges, solid wedges going around. As each one of them, they're all the same. Basically, they're all the same. And you're just shifting them around the pole, support post. And the thing to remember is that the front edge of the riser above is in line with the back edge below. So it's another word problem. You gotta remember, front edge lines up with the back edge. Front edge, just for simplicity purposes. Sometimes they overlap a little bit as they shift them around the pole, but for our purposes, to show it like this. And then as they wrap around the post, you can see, right? You're gonna see different edges wrap around the post in elevation. And that's what you're seeing here. As you look head on, you're seeing the curved edge of that wedge, but then also the flat face of the risers. See how that? They kind of keep walking around and then it's walking around the pole. Again, this one gets tricky if it switches on you when you look at it. So here's what's happening. Here you're seeing the full wedge face of the riser. Front edge becomes the back edge. And then from plan, again, you're going to be projecting from plan, the front edge, look, the front edge, again, these are taped down, they have to line up. The front edge is this one, and then it becomes the back edge below. You gotta keep them straight, just do one at a time or you're gonna get lost. Okay? So you do that.
You head now?
Okay, so I'll see you online then, next week. So, and then just imagine, sometimes the shading helps with the visualization of that curved wedge. Now here, I don't know why, again, you shouldn't have shaded everything. So again, don't look at these too closely. I'm just using this as a guide. But here, you're seeing the outside wedge, the surface of the curved part. Here it goes around. Now here, this is the back side of the wedge. So it's the back side of it. As you're going around, here you're seeing the wedge, the outer wedge. I'm standing here, I see the face of that riser, I see the face. Here I see you're just on edge. There's one line, but I see the outside curve. Here, I see the outside curve of the wedge, but I don't see the face. I see the back side of this wedge. Right? So this back edge will drop down and become the back side of the wedge. Does that make sense? Okay. And that's what you're doing. You're kind of showing it all the way around. But again, the front edge becomes the back edge of the wedge below. And so you don't see the face again until you get here, underneath. You stand here, you're gonna see this riser here, and you're gonna see the last one here, and that's what you're getting. And also dashing in where the back edge of that curved ends. There's a little curve on here that goes around like that and it stops here. That's what she's showing. She's doing that right. She's showing where the wedge hits the pole, see? As it goes down and around. There's lots to project on these. So there's where it's tangent. Here it's starting to get in front of the support post. In front. Right in the middle, and then here it would be dash, because you're not going to see it, you're looking through a solid wedge, so the dash as they hit. If you get all that, don't worry about it. If you don't, the main thing is this outside, okay? You know, she did a really nice job projecting all that. And then the same is true for the handrail. Similar to the circular, you imagine where that point is, take it down to where it hits, measure 3 feet up, that's all you do. And then just use a French curve or a flexible curve and connect the dots. And then again, it's dash because it goes behind the other side of the stick. So again, don't do segments, just do one smooth curve, which could be done. So again, this is open wedge, kind of stacked wedge risers. We could do, you know, an enclosed one if you want. It's just as nice, you know, and you've got a smooth bottom. But I would still want to see it all dashed in here, like what you show. And again, that's close enough. So you just see the little subtleties is going around tighter. Again, really a sculptural, pretty stick. Any questions? So let's do the height. The overall height for these will be for circular, let's do plus 13 foot 6 inches. And this one we'll do plus 9. Let's keep it simple. 9 feet 0 inches. There's your floor to floor height for those. And we already said 6'6" diameter. The post, no, you know, start at least 6 inches. If you get too big though, you have to maintain this minimum dimension. So that's what I mean. If you made it bigger, you might have to adjust your diameter. But don't get too big, because then it's a circular stair. That should do it. Fun, 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 right? Again, these two are again, bigger scale, 1/2 inch equals a foot, so you can see why, right? There's just so many little fine points that you're projecting. You gotta keep track of it one at a time. All right. So here's, I'll leave that on.